For the CircuitPython Parsec today, I wanted to talk about how to use a button bitmask with Seesaw inside of CircuitPython. That's right. It's so easy to say. So when we're using a Seesaw chip, such as the one on this little Gamepad QT plugin, we get the benefit of talking to our microcontroller over I2C and taking care of little GPIO things right on board with the little Seesaw chip. And to keep things fast, we can send bundled up little messages about what's going on this external board, so that we don't have a whole slew of messages to get across the idea of, let's say in this case, 6 different button states. So the way this is done is with a bitmask. In the case of this Seesaw breakout for the buttons, and I'm going to ignore the potentiometers of the thumb stick there and just talk about these 6 buttons here. We have A, B, X, Y, select, and start, just like a little game controller. If you look down in the REPL there, when I press a button, you can see the A button, I'm making the letter A capital, B is capital, X, Y, select, and start. So let's take a look at this first example of the select button. When I press that, all of these are pulled high. These are buttons that are pulled high, and when they press, they go to low, they go to ground. So you can see some values in that binary output there that has all the zeros and ones. The very farthest to the right says 1, so that is the current state of this select button. When I press it, it goes to 0 because it's gone to ground, and the message contains the state of all the buttons. So you can see when I press 4 of them there, we have 4 of those 1s going to zeros, as well as my little capitalization there. So this 1, it's actually a 16-bit integer that gets sent, and then I'm unpacking it into binary here, as well as these little strings. This 1 message conveys the state of all of those buttons. The way this is done is we're going to import the Seesaw library. Then I'm going to specify which pin each of those buttons is on, and that's just in the documentation for this board here. So the, for example, select button is on pin 0. That's why it ends up being that very first one. The start button is actually pin 16, so that's going to be very far off to the left there. Then we create this button bitmask. So this is the variable that contains the pin assignments for all of those buttons. And then in the setup here, we say, hey Seesaw, pin mode bulk, so take a whole bunch of pins and set them to input pull-ups. So that's a little convenience script there that sets up all those pins to be input pull-ups using that variable, that button mask that we came up with. Then in the main loop here, you can see I'm casting buttons to equal a big bulk read, which is digital read bulk and the button mask. So that grabs that full set of values there. Then we just have some parsing of that so that we can display that on screen. But if I just need to use that for, let's say, a game, we're just going to read this and then ask for those individual values of buttons. And so you can see here, as I press these, we get a nice efficient single chunk of data that contains all of those buttons all at once. There they are, all getting pressed at once, and we don't have to wait around for them as if we were asking multiple times. And so that is how you can use a button bitmask with Seesaw inside of CircuitPython. And that's your CircuitPython Parsec.